C03CAF3 just redeemed stretch.
Oh, oh wow, cool. All right. Sorry, it took me a while. Hi, good morning. Today, I don't know why, it was hard for me to start the day, just felt really sleepy. So yes, I need that stretch. Thank you. And good morning, coffee. Good morning, Keen. 시비. 안녕하세요. 좋은 아침이지. Good morning. I have a thing with the good morning in Korean because normally they don't say good morning, but because a lot of, that's what I understand, because a lot of language learners like what use it, then they started using it, and that's what I think. Again, it might not be true. And why are we slow? Are we good? Okay. And now you can see them say "chunachim" in TV shows as well. But then when you tell someone "chunachim," someone who's a language learner, they're like, "No, that's not Korean. They don't say good morning." And now I'm like lost everywhere, which is fun. But yeah, even like yesterday I saw somewhere that "chunachim," which is, yeah. 안녕하세요 is probably like the easiest thing, which is not today's topic. Today's topic is, I don't know. Let's see. What is today's topic? Dataset library. Okay, what's in the datasets library? Let's see. Also, even though I had a hard time waking up today because I slept a bit late, like half an hour late yesterday, I don't want to start here because then I'll probably fall asleep. I'm kidding. No, I'm awake. I promise. I had to make coffee. That's why I'm a bit late. I mean, I didn't have to. I wanted to make coffee. There we go. That's it. So let's start. Yeah. Because there's a part of me that felt guilty for not studying yesterday, and a part of me is like, why? You don't have to. They're currently fighting, and I saw I saw the statistics from YouTube, not Twitch, telling me that, well, also Twitch, but yeah, that I streamed for like 1 day and 1 hour in May. So here's to June. All right, we are in the HuggingFace NLP course, Chapter 5, the HuggingFace Datasets Library. Okay. Introduction. In Chapter 3, you get your taste of the HuggingFace Datasets Library and saw that there were 3 main steps when it comes to fine-tuning a model. Load a dataset. We always need to take a break. Thank you. Thank you. I guess in a way, having the habit and not breaking the habit is like a good thing. So yeah, me doing an hour of learning in the morning, even if it's not NLP, is still the habit of like, I have to wake up so that I can stream. Otherwise, I'd rot in bed, you know? Load a data set from, yes, we did that. Pre-process the data with, yeah, I mean, you do stuff and then you map the stuff, okay? And then load compute metrics. Load and compute metrics. So we get it, we process it, we do some compute metrics evaluation stuff. Saying you streamed like 1 day and 1 hour confused me for a moment. Yes, that's 25 hours, which is a lot. Yeah, like it sort of surprised me because just the 1 day part surprised me more. Because like 25 hours, I saw that when I gained some sort of achievement on Twitch telling me you streamed more than 24 hours in the last 30 days. But just seeing the 1 day was like, oh wow, that's a lot. So metrics matter, I guess. And that's why we compute metrics. Good segue. But this is just scratching the surface of what the HuggingFace dataset can do. In this chapter, we will take a deep dive into the library. Along the way, we'll find answers to the following questions. What do you do when your dataset is not on the hub? Are we making a dataset? I would love that. How can you slice and dice a dataset? And what if you really need to use pandas? Do you really need to use pandas? Why not? Let's do that. What do you do when your data set is huge and will melt your laptop's RAM? That's funny. You use stream. I know the answer for that. You don't load the data set, you stream it. Where did we learn that? Where did I learn that? Anyway, what the heck are memory mapping and Apache Arrow? I have the same question. I really like the fact that these questions are written in a funny way. How can you create your own data set and push it to the hub? Yes, I love that. Please teach me. I need it. The techniques you learn here will prepare you for the advanced tokenization and fine-tuning in chapter 6 and 7. So grab a coffee. I already have. Oh my god. And let's get started. I was born ready. Okay. Oh, are these each the questions? Fun. So, what if my data set isn't on the hub? Go cry in a corner. Okay. You know how to use the HuggingFace hub to download data sets? But you'll often find yourself working with data that is stored. Oh, I forgot. Oh my god, what's wrong with me? I literally, when I sat down, I was like, I'm going to play the soft murmur background thing, and then I forgot. Is that alright if I play it? Because I actually like it. Is it playing? There should be a whoosh, which is sound of waves. Is it? And then sound of trees burning? Waves, fire, and coffee shop. That's all the sounds I have on. Okay, sorry. Why did I think of that? Anyway. Sound should be okay. All good? No. Oh, wrong button. There we go. So, working with data that is stored on your laptop or on a remote server. True. In this section, we'll show you how HuggingFace datasets can be used to load datasets that aren't available on the HuggingFace. What? We're going to load datasets that are not available on the hub? How does that work? Meaning like datasets that are just like APIs? I mean, okay, that makes sense. I think an example would be MNIST. It's on... Is it on Jan LeCun's website? Because I remember last time just thinking about trying to load it and failing. Okay.
Loading a custom dataset.
Ah, loading a custom dataset. Okay. I was watching a video from Braincraft about, it was interesting about how to deal with hard times. And at the end, she was telling the camera person, like, why are you saying data? We say data. I was like, oh, that's fun.
Although the HuggingFace Hub hosts over 1,000 public datasets, you'll often need to work with data that is stored on your laptop or on some remote server. In this video, we'll explore how the datasets library can be used to load datasets that aren't available on the HuggingFace Hub.
Okay.
As you can see in this table, the datasets library provides several inbuilt scripts to load datasets in several formats. To load a dataset in one of these formats, you just need to provide the name of the
I think the normal way, like most datasets are just CSV, right? Like the ones that we have been loading till now were CSVs, I think.
format to the load dataset function, along with the data files argument that points to one or more file paths or URLs.
Is he being low? Oh wow, I'm really louder compared to him.
To see this in action, let's start by loading a CSV file. In this example, we first download a dataset about wine quality from the UCI machine learning repository. Since this is a CSV file, we then specify the CSV loading script. Now this script needs to know where our data is located.
Thank you. Sorry. Is it good? Let me know. I'll try to turn on CC, but I know my the thing at the bottom makes it. Let me make the sound of the background noise lower. Okay. And then I think now the video should be loud, like the same loudness as I am. Okay.
Specify the CSV loading script. Now this script needs to know where our data is located.
Thanks.
So we provide the file name as part of the data files argument. And the loading script also allows you to pass several keyword arguments. So here we've also specified that the separator is a semicolon. And with that we can see the dataset is loaded automatically as a dataset dict object, with each column in the CSV file represented as a feature. If your dataset is located on some remote server like GitHub or some other repository, the process is actually very similar. The only difference is that now the data files argument points to a URL instead of a local file path. Let's now take a look at loading raw text files. This format is quite common in NLP, and you'll typically find books and plays are just a single file with raw text inside. In this example, we have a text.
Oh yay, Tiny Shakespeare. The other day, Andre Karpathy was using it. Okay.
File of Shakespeare plays that's stored on a GitHub repository. And as we did for the CSV file.
Oh, it's his. Wait, it's his? Whoa. That's cool.
We simply choose the text loading script and point the data files argument to the.
Hi, JSS. Good morning. Or good evening, I think. We're learning about HuggingFace datasets, library, and how to deal with stuff that are not there, or how to make our own stuff.
The URL. As you can see, these files are processed line by line, so empty lines in the raw text are also represented as a row in the dataset. For JSON files, there are two main formats to know about. The first one is called JSON lines, where every row in the file is a separate JSON object. For these files, you can load the dataset by selecting the JSON loading script and pointing the data files argument to the file or URL. In this example, we've loaded a JSON lines file based on Stack Exchange questions and answers. The other format is nested JSON files. These files basically look like one huge dictionary, so the load dataset function allows you to specify which specific key to load. For example, the squad dataset for question answering has this format, and we can load it by specifying that we're interested in the data field.
Okay.
There is just one last thing to mention about all of these loading scripts. If you have more than one split, you can load them by treating data files as a dictionary that maps each split name to its corresponding file. Everything else stays completely unchanged, and you can see an example of loading both the training and validation splits from Squad here.
Oh, wait a second. Oh, like this. Ah. Because the other example, just a URL, and This data here, I don't know what it's referring to because I don't see anything saying data, but fine. And here we have train. We're putting them together ourselves, making the dictionary.
Name to its corresponding file. Everything else stays completely unchanged, and you can see an example of loading both the training and validation splits from Squad here. And with that, you can now load datasets from your laptop, the HuggingFace hub, or anywhere else you want.
We just give you the URL and then that's it. Pretty cool. Working with local and remote datasets. JSON lines didn't seem obvious, but I think maybe it's a good way to stream data without parsing the whole file. Maybe. I'm sure we'll see examples. I think the streaming comes later, but it seems that way. Sorry, I need to bring the frequency back to English only. Working with local and remote datasets. HuggingFace datasets provides loading scripts to handle the loading of local and remote datasets. It supports several common data formats such as what's TSV? Okay. What about space separated? Comma separated values or tab separated values? Okay. Oh, thanks. Sorry. I mean, not sorry, but like, thank you also. Yeah, I was about to say, if it's coming from HuggingFace, we don't need to tell it. But if it's coming from elsewhere, we probably need to tell it. Pickles as well. Cool. Pickles or pandas? Good to know. As shown in the table, for each data format, we just need to specify the type of loading script in the load dataset function, along with the data files argument that specifies the path to one or more file. As you see, CSV, with CSV they specified the actual separator to be semicolon. There is an example, yeah. I think of them as families of formats rather than a specific one, right? Yeah, just a CSV with the type of separator. Maybe it's comma, maybe it's tab, maybe it's space, maybe it's semicolon. There are standards some CSVs might use that describe like escaping, etc. Okay. Yeah, when doing the cell to column thing on Excel sheets, that the separation sometimes is just funny because it loses stuff. Yeah, my brain went there. So, where were we? Okay, so let's start by loading a dataset from local files. Later we'll see how to do the same with remote. Hold up, how is... are we downloading it? How's it local? The commas are in the data file. CSV, yes. Are we talking about when it becomes funny? Or are we talking about normally? Yeah. And then when you take data from users, you're like, remove all commas, otherwise it will just ruin everything. Loading a local dataset. Okay. We are using Squad. What does the it stand for? I think I know what Squad stands for. Large scale dataset for question answering. Italiano. Okay, okay, the IT was for Italiano. Pretty, okay. Whoa, 6 years ago. Don't know what GZ is supposed to be. It's alright. Okay. Oh, large scale data set for question answering in Italian. I have zero patience, right? I thought you were referring to the code, my bad. No worries, thanks. Depends on the CSV parser, like Excel saves CSV. Well, put quotes around text with commas in it. True. In cells, if you just put one enter or like character turn and all that, you will see it's like my biggest fear. When you copy from Excel and you see commas, they're like, ugh, and then it's just one line. For CSV, if you save it as CSV. Okay. But sometimes there's an enter at the end or enter in the beginning, and yes, God save us all from unclean data, which is everywhere. The training and test splits are hosted on GitHub, so we can download them. Are we doing that on Colab? Let's do that. So we're downloading it and then loading it. wget. I was about to say widget, but nope, that's wget. This will download 2 compressed files, which we decompress with the Linux. Whoa, that's really fancy. Let's make a copy and lazily just run the stuff that's there. I'm not feeling like writing stuff today. Go. And after that, you can go, because I'm guessing it should take time. We are using this. You didn't tell me what this stands for, so I'm gonna Google it. I was expecting you to. I don't know what that is. File type. Type, extension, whatever. What does it stand for? Someone. GNU project? Zip for GNU? Okay. It's a gzip format. Tamam, got it. GNU zip. Okay, so it is Linux. I guess made from and with Linux. We have our. There's some red text that I will not read unless it messes with my. Incompatible. Okay, what do you want me to do? Colab is. We'll see. That was fast. 1 second. I expected it to take more time. And then we do the zip thing. That was pretty quick. Yeah, 87 to 82. Yep. We'll see that the compressed files have been replaced with JSON files. Nice. It's stored in JSON format. Do we see them here? We have both. If you're wondering why there's a exclamation point character, because we're running them with a Jupyter notebook. If you remove it, if you're doing it with a terminal. Got it. To load a JSON file with the load dataset function, we just need to know if we're dealing with ordinary JSON similar to nested dictionary or JSON lines. my hand. There, okay. My hand became tired and I don't want to go back to physical therapy, so I'm using the mouse. I was at physical therapy last year because my arm was tired. You might be used to .tar, .jz files, which are kind of free software equivalent of zip archives. And who said zip archives are not free? I don't know. Okay, similar to line separated JSON. Like many question answering dataset, Squad uses the nested format with all the text stored in data fields in the data field. Okay, this means we can load the dataset by specifying the field argument as follows. Okay. Alright, so we're just saying it's a JSON file. This is the file's name. And data field is data. And because like we're not putting it in any folder, that's why we're just calling it. And it's loaded. Generating? 3 seconds, okay. Was kind of proper format of a program. Like a thing before it called PKL zip, like how once upon a time. Yeah, I know, we needed WinRAR to deal with RAR files. Okay. Cool. Yeah, I felt sad when I didn't need to have WinRAR to open these files. Okay, so we have a dataset, training dataset. Anyway, tar is like tape archive. Stores multiple files together but none compressed, and then the whole thing is compressed by gzip. It's like a 2-part thing. 7-zip is all you need. I actually just use yeah, we remember WinRAR. Each time you open it, it's like, are you going to donate, or like next time. But I don't use any zip programs. I just use whatever comes with Windows. I think I use it on the Mac. I don't know. I remember, no, wait, I think it, I don't know. I remember having to unzip something, and then I think most of the time it does that itself, but if it's a different type, maybe it's zip versus RAR, I don't know. So, this is the training set. Why? Because we only loaded the training set, got it. And it's 442 rows. And to look at one piece of the data, whoa, what is that? We have an ID, a question, answer, start, 21, wait, is this, well, why is it so? Am I not supposed to be looking at one thing? Did I run the whole thing by mistake? No. My emoji is eye tracking 100%. Yes. I think so. Why? Am I... the program is doing all the eye tracking. Like I can roll my eyes and be like, ugh, fine, whatever, and it looks like it does it, right? Also concentration, like I look like I look angry even though I'm like focusing, and then the eyebrow raise and all that. It's doing a good job. Paragraph, context. Oh, we have a context, and then we have 90, 20. Oh, we have answer start, and then we have text, and then ID, and then question, and then answer. What's with the answer start? And where's the answer? Anyway. Okay. Let's go back here. By default, you can tell when I'm thinking. There are some actually really cute things. There's one that I really like, but if I press it, I hope, let's see if anything. Oh, okay, that's good. There's one, you can't see it right now, which is pretty good. I really like. Wrong place? Yes. Okay, I'll find it. But like, it takes a lot of time, that one, to load it, and then to see. Now this is real thinking. It's cute, right? But it takes me a long time to add and then take away. I mean, I could still do it, but looks like I'm thinking. I'm gonna take it away now. There, loading done. By default. Local files. Loading local files creates a dataset dictionary object with a train split. I mean, we loaded the train split, so yeah. We can see by inspecting the object. Okay. And then this shows us the number of rows and column names associated with the training set. We can view one of the examples by indexing into train split as follows. Should I do a 0, 0? Because this is like way too much. Would that be an error? Yeah, fun. Okay. But why is the first things like, are there 20 questions per context? No, there's another context. Oh well. Great. We've looked into our local dataset, but while this, also my eye betrays me when I try to look at chat, because there's a screen up here, there's a screen down here, and I'm like, is there anything new? Okay, all good, go back. But while this worked for the training set, what we really want is to include both the train and test in one single object, so we can apply the map. Okay. Functions across both splits at once. To do this, we can provide a dictionary to the data files argument, like this, and that maps each split name to a file associated with that split. So we say train, this is the name, test, this is the name. And then here you go. Okay, that's pretty good. Thank you. Okay. Good. It's exactly what we want, and now we can apply various processing techniques to clean up the data, tokenize the reviews, so on and so forth. Okay. The data files argument of the load dataset function is quite flexible, can be either a single file path, list of file paths, dictionary that maps splits to file paths. You can also glob files that match a specified, I don't know what glob means, specified pattern according to the rules used by the Unix shell. You can glob all JSON files in a dictionary as a single split by like wildcards. Ah, okay, that makes sense. Okay, got it. Okay. Oh, like this. There we go. Yeah. Okay, so give me all the JSON files. See the documentation for more details. I'll briefly look at it. Pretty. Documentation is pretty. Oh. What? What? You can write SQL? That's so lovely. From SQL, got it. Glob wildcards are like the ones like star you might use in git ignore. Like just regular expression, basically. Arrow. What? Arrow is a data type? Parkey? What is that? And then JSON, and then that. So pretty. Okay. Documentation. Very pretty. Can I? Oh, what did I do? Same as ls star JSON or directory star JSON. Thank you. That is really useful. Okay. We have documentation if we want to go here, because I'm sure we'll need to come here sometime in the future. Huh. That last one I don't think I recognize. Because like going back, dynamic path, but that doesn't look like a dynamic path, right? Star measures subdirectories. Cool. I know the thing for going back when you're in a terminal. Awesome. I learned about the word glob. The loading scripts in datasets actually support automatic decompression. We have a thing load, right? Of the input files, so we could have skipped. Oh, really? By pointing. How? Because like this is the compressed, and if you say JSON, would it just decompress just like that? No way. This is that? It's fun. I was like, to consider it called all as opposed to glob. Wait, that thing is called glob? I also consider it as all, like star, you know, select all from, yeah, that's true. This is a star. I call it star. I hope we can decompress on the fly to avoid having the full file decompressed. When it comes to streaming, we'll see. Because I'm sure this is doing the full file decompressing. But let's see. Okay. So this can be useful if you don't want to manually decompress any gzip files. The automatic decompression also applies to other common formats like zip and tar. So you just need to point data files to the compressed file and you're good to go. Now that you know how to load local files on your laptop or desktop, let's take a look at remote files. I mean, yeah, you just give it the URL. I guess if they have different names, then that part. Asterisk all in this case. Wait, I wouldn't call wildcards along glob. Is it just the star? Glob is just a play on words. It seems non-intuitive. How is it a play on word? Does it stand for something? Why am I being so hee as in everything? As in globe? Computer programming globe patterns specify sets of file names with wildcard characters. For example, give me a better. Is this supposed to be globe? Has wildcard, not everything with wildcard is glob. Good to know, good to know. Bell Labs, everything goes back to the glob command, short for global. How is it more easy to say glob than global? Get out of here. Search. Star is enough for search. Glob. Got it. Okay. Who gave the, reins to computer scientists? Sometimes they're good at naming things, but not always. Not always. So, if you're working as a data scientist or coder in a company, there is a good chance that data sets you want to analyze are stored on some remote server, probably. Global glob. This makes me think of a joke that doesn't make sense. Oh yeah, it does. Wait. In English, there's the naan bread, which just means bread. So yeah, global glob. We have the same joke in our language, but for a different thing. Yeah. Okay. Fortunately, definitely fortunately, nothing unfortunate. Loading remote files is just as simple as loading local ones. I know. Instead of providing a path, we pointed data file argument of the load data set to one or more URLs where the files are stored. I guess when you are trying to make a multi-user mainframe where every byte counts because RAM is sold in kilobytes. Oh, that makes... For coding, they shape the characters where they can. That actually makes a lot of sense. We are spoiled right now, aren't we? Wow, no way. As in 4 kilobytes? RAM PC? I don't know what we had, but we had a computer early 2000s. Now I'm curious what the specs were. But I guess early 2000s, I don't know. Late 90s, early 2000s then. For the squad Italian dataset hosted on GitHub, we can just point data files with a star. Or why are we putting the star? Train or test. Because we want to name it, I guess that's why we are not putting the star there, but we could do the star, right? We should. What a way to unshow identity? Thanks? Is that a good thing or a bad thing? Saranj? Hi, welcome. It was a kid computer. Ah, you built it yourself. Whoa, whoa, whoa. That's really cool. Wow. This returns the same data. Okay, so let me try to load that. I think that's what we have. This is URL test train. Go. Oh, can I? Is it the same thing? Are we just? Run. Yep, same thing. Test and train. Nice. This returns the same dataset dictionary object obtained above, but saves us the step of manually downloading and decompressing the files. This wraps up our foray into the various ways to load datasets that aren't hosted on the HuggingFace hub. Now that we've got a dataset to play with, let's get our hands dirty with various data wrangling techniques. I love data wrangling techniques. Try it out. Should we try it out? Pick another dataset hosted on GitHub or UCI. What's UCI? Machine Learning Repository. UC as in University of California. Oh my god, isn't this like the oldest thing? The Iris dataset? Whoa. What else is there? Fishing. Rice. That was loud. Sorry. Can I filter by something? Dry beans. Oh, that's adorable. View datasets. Task. Huh. Classification, regression, or clustering. Subject area. Data type. I keep searching for audio and see none. It's fine. Sure, let's just do text. SMS spam collection. Online retail, 1 million instances. That's too much for me. Give me something 20 news groups. That seems, oh no, that one's smaller even. Do I just take this? Is there other URL that I can use? I don't want to download it because then it would go, but I can take this. Usage? Anyone? Donated. Fun. I can imagine someone using ML to identify grains from other things that might have gotten into a silo. There's the famous example of, I think it was published on some Google blog, the cucumber farmer separating, I think, healthy and unhealthy cucumbers, something like that. So yeah, are rice grains in silos? Maybe. So I'm gonna try this URL, and I don't even know if it has a training and testing. I'm just gonna try it as is. So that would be the URL. URL. Hello. Amen. Need help going to pursue masters in AI ML. Any advice for the admission interview from where I can study basic AI and ML? So you want to prepare yourself for an interview? Is it anything in particular, or is it like a... Oh, you said masters, not bachelors. Like, do you have particular interests? Because maybe knowing some famous... not even papers, just like names of things might be useful. And I guess... Is there... Oh, how much time do you have? Also, I had that question. Because, like, do you have enough time to do a course? Do you have a week? Or do you have, like, one day to just do something really fast? Let's get our spam data set. Just basics, I guess, for selection. Also, how much time? Do let me know. I think that matters. Oh. Next 5 days. Okay, that's actually not short. That's good. I don't know if that's a good advice, but like the first place I would go is Wikipedia because like it has the basics and the newest things most of the time. But then I don't know, like we're studying free online courses at the moment, like on HuggingFace and from lectures online. True. But I have a video on my master's and people ask me about master's degrees. Ayman, I have a thing. Let me bring it up. Just one thing. I don't know how useful that is, but I do believe it to be useful because I am a crash course AI. Do you know about crash course AI, Ayman? There we go. It's from 4 years ago, maybe not as updated, but it's pretty updated. Genuine videos? Why can't I click? There we go. I wanna send this playlist in the chat. I do believe this will, if like you're new to it, I think this will give you just a rundown of things, because like it's mostly talking about a lot of things but in 10-minute videos. I think that's helpful because it's a crash course. Get it? I know. Should we? Brilliant sponsorship. I actually, when SciShow first did a Brilliant sponsorship, I signed up and just like used it. Does it cover algorithms? I doubt it. I doubt it goes that deep. Oh wait. Oh, I thought I thought you were saying get a sponsorship for Brilliant. But I 100% want to like do ads for anything that Hank and John do. I love them. You touched it some daily back then, yeah. Oh, of course. You're welcome, Ayman. Good luck on the interview, and I'd be interested if you'd like to update me after it happens. I really think the fact that I don't know, maybe students are better these days, but I think not a lot of people try that hard. So I hope that the fact that you're trying shows to the teachers and interviewers. Because I remember when I did my master's interview, and one of the I said I'm interested in ML, and one of the interviewers asked me about neural networks, and I didn't know about them. So, and then I got in. So I hope even if you don't know stuff, show that you are open to learning and like eager to learn. I think they want that more, because they don't want a closed book. They want someone ready to learn, and someone who's willing to try hard. I mean, it's a university. They want to, they want someone who is willing to, how do I say, not, God, what's wrong with me with talking? Yeah, that's the point of learning. Yep. Yeah. I'm just saying that universities are not the best. I enjoy being a student. And I continue applying to do degrees, which is, not the healthiest thing. But I hope that the teachers are people that have your health in mind as well. Cortex in culture was awesome. I don't know what that is. Not sure how much development kept it going. May have fizzled. Good example of companies with money stifling competition. I actually don't know about that one. Don't forget to like and subscribe. You're the sweetest. Thank you. Sometimes we forget where we are. This is YouTube or Twitch. I'm gonna ask for JSON. Is the background sound calming? Because it feels calming. URL. Should we add more thunder? I'm gonna say field data, but I don't think that's the case. I'm expecting this to fail. Let's try. Does your master's in software engineering cover a lot of ML and AI? Did not. Nope. It was mostly me and the supervisor. And I don't I didn't really learn because that was like a while ago. Things have changed. I just learned what I needed to learn for the project. I did some online courses even then. But they were a lot more rule-based and the things that I used, I'm saying. Yeah. We had, I listed what I studied, but yeah, like software requirement. I by the way, I'm reading from a list that's in front of me. Software requirement engineering, software project management, advanced OOP, software architecture and design, cybersecurity. There was another one I can't see from the list right now, but yeah, just software engineering stuff. But another student in my course also did some vision as well. So yeah, the students were interested. It was like a new thing back, not really, but like a new thing. So what is our error? Bad characters from the blacklist are found. Where? The plus? The plus. No. I'm gonna go on GitHub because I can't get the link for this. And I don't want to download it. And if I cite it, does it have the link? I don't think DOI is not the link for data, right? Was cybersecurity cool? Yeah, I mean, there wasn't much practical, but we were reviewing code. So, and there was this, like overall, I did learn a lot more than I knew, but right click, download to get, that's what I did actually. This is the link that I got, copy linking from download, but it's saying it has bad characters. Yeah. Why are you giving me error? That makes no sense. Bad where? The HTTPS? Oh, forward and back. Seriously? This had the same thing. Okay, I'll do this thing and try it. To answer the cybersecurity thing, I did presentation about this thing that just came out, and it just made me lose faith in all computer science. Can I find it? It was I forgot, but I'm going to try and find it. Cybersecurity something attack, maybe? Nope. It was named something ghost, and I'm trying to find it, but now I can't find it. Yeah. Okay. I guess there are a lot of ghosts. Oh well. Maybe next time. Weren't you meant to wget and give the local file? That's just an example. I mean, we had both. We had the remote and then local. I'm doing remote. And see, it's coming from GitHub. Did a MOOC course online that was very practical, and I think if it's still around, might be fun. What's the name? I don't know if I'll be able to do it, but I'd appreciate if you can share it with the class here. Okay, I'm gonna try this thing here, and if I fail, then we fail. Double checking the sound because I hear dogs barking and you can't. Yay. Or maybe you can when I'm talking. They're quiet now. I don't think this will work, but I'll try. This makes no sense. It's literally the same thing. Oh, wait, did I forget to tell it? Where did we do URL? I guess I forgot to say data files? Does that matter? Let's run it and see. Actually, I remember there was a Harvard CS50 Introduction to AI, which was pretty good. That is a good example. And also I have errors. Fine. Okay. Oh, you were trying to generate it. If Amen is still here, I also agree with the the CS50 AI, and I can. Would it be alright for you to link it, or should I try to link it? Introduce the process, pre-processing, optimization, training, and a bit of NLP. I mean, I'm sure he wants to focus on everything and not just NLP, so that would be really useful. I've been trying to pronounce Amen's last name, and I keep going, what's Mazhar? And I just realized it's Mazhar. Okay. I think my current pastime is downloading worked. Hold up. If downloading works that way, then my error was I didn't give you this URL like this. I think it is. Yay, don't. Okay. Oh no. Still same error? Okay. Have fun. I'm gonna go now. Documentation. Let's look at documentation. Tiny bit. Where is remote, local and remote? Can I ask for a zip file? I guess not. We don't have a test and train. It is URL. Looks like it's no longer available. It was cool. No way. It's not available? Okay, there's the cybersecurity one. Did their fun one, like exploiting buffer overflow in a C program to perform an exploit. Did we do, or did we look at code that does it? I don't remember. That's fun. You're like, okay, sorry, I was focusing on this. When you can play around in a computer, it makes it more fun, I guess. Base URL and then do we say split train? I don't think I need to do this field data, I guess. Wait, go back. Okay. And then one more. And then if I say this is the split train, would you work? No. Unable to find why? That was loud. Oh, what? Oh, my splitting was wrong. Whoops. Then if I give you the whole URL? Oh, what's wrong with me? Something, I bet. I don't know what it is right now. Paste. Are we working? No. Same error. And if I give you the full URL without giving you the splitting, and also, whoops, paste, and no train, just URL. URL. Same error? Okay. I'm out. Patience ran out. Processing. That's pretty long. I'm not gonna do this right now. But looks like fun. We have sorting, shuffling, splitting, selecting, sharding. Don't know what that is. Rename, remove, cast, and flatten. Mapping. Concatenating, interleave format. Save and export. Love it. Looks amazing. Oh no, I'm in... What just happened? Why? It took me... I was in documentation. I mean, that's pretty long as well, but... Yeah. Anyway. I was just reading this, alright. Was it looking for a split there that wasn't? At first it was, but now it's not. I'm just giving it the whole thing. I am not using this anymore. Like, this is the URL. I don't know if it's... I don't think there's Should I go back? Load datasets. I don't think we have anything that is just URL, because even here they are doing the train validation, all of that. And yeah, maybe like a raw dataset won't be divided into splits, maybe, but it's okay. I could probably do Tiny Shakespeare. Can I do Tiny Shakespeare? Is it linked here? GitHub video. Where is Tiny Shakespeare? Should I Google it? Tiny Shakespeare dataset. There we go. Oh, hey, there it is. And that's it. Again, this is just one thing. So how would that work? I'm gonna update this. Paste. This is a text file. Would it work just like that? Yep, it did. No splits. Oh, it's no longer. It's a tiny data set. There is something wrong with the data set, I suppose. It is text and 40,000 rows. And I think, like, if we do row number 1, we can't. Oh, you generated, thank you. Train. First citizen, yeah, that's it. I have no idea what's going on, nor do I. Life is confusing. Hello, Free Tioi? That's an interesting name. If you have the time, I will tell you what I'm doing. Which is, there's this website called HuggingFace. And it's a place where people do AI and ML stuff. And I'm logged in, so this is not the main website. I have no idea what's happening. They have this thing called Learn, their online courses, and I'm taking this NLP course 2 minutes ago. Welcome. Yeah, I don't know if you're interested in ML and stuff, but they have their NLP course and other courses from HuggingFace. Do you know about HuggingFace? Because they might be a bit niche, I don't know. Less data is more. Is it though? I think people are too greedy for data. It's never less is more. Yeah. But just because our new friend has arrived, the dog URL is so cute. Is it? Yeah. Look at it with the tongue out and everything. Oh, there's no. Okay, there's a dog. There's a dog. Just because our new friend is here, we're going to change lanes and go to the CMU. Pretty deep into a lesson today, but if you stick around, my start makes sense. Slowly machine learning is a lot. Also, if you're interested, you can try taking the course, or I don't recommend it, but you can look at the backlog of all the previous lives that I've done. Today is number 14, so there are like 13 more videos waiting. You don't have to. You really don't have to. I'm just saying it's available. And yeah, they're mostly split into 2 parts. One part is the HuggingFace and the other part is the CMU. And we're going to start CMU. When I play it, do let me know if the sound is alright, because maybe it's slower. Forgot about Python completely. I don't know if I'd understand it. the thing about the Hugging Face part is that they actually like, oh, we're looking at how to get data into a machine learning environment to the ML model. Yeah. The thing about this Hugging Face course is it like holds your hand during the process. It tells you everything that's happening. I know a bit about Python. I've used it, but not in this ML, like notebook style place. So you are in a good place because I feel like I know nothing, especially with the CMU course. Like the words he's using are so dense. But you know, we just sometimes I don't understand it, and that's okay. Yeah. ML ops. No worries. Oh, okay. Python is easy to pick up, but also sometimes, like, when I don't know what to write, that frustrates me. How to write it, that part. Like, I can probably understand a code, but if I don't know what I want to write, then that sort of is annoying because I guess I don't have enough information about the library I'm using, you know? ML Python like NumPy and PyTorch seem like a different language to normal Python. It actually does. It really does. Sometimes. It feels that way for me anyways. Okay, that's Tiny Shakespeare. We loaded this data using load dataset. This is what we learned today. Okay, class, I'm going to play this. Do let me know if there's any issue with the voice. Please be quiet, sit down, and let's go.
12:30.
By the way, don't be quiet, I'm kidding. You can chat. It was supposed to be a joke.
Are there any questions before we get started?
I think voice is good. Looks pretty good. You've done scratch models from papers? Yeah, Professor Allgood. Lovely. Wait, you mean like models from scratch? That's... Papers are not... I don't know. I can never recreate stuff from journals and papers. I don't know if you mean real life papers or you mean published papers.
Okay.
Sorry. I paused the professor again. Hypotheticals are not my most fun things. I remember one of my lecturers saying that back in his days, and he was like 5 years older than me, back in his day, they were doing punch cards. I think that's what he said. Maybe he was older than 5 years, I don't know, but he was not that old. I'm just saying, punch cards and writing your code on paper and giving it to a computer and all of that. He was flexing on us. Anyway, I have around half an hour, so let's see how that goes.
I don't see any, so I guess we can jump right in.
Okay.
This time I'll be talking about sequence modeling, and first I'm going to be talking about why we do sequence modeling, what varieties of sequence modeling exist, and
Yep, punch cards. But he was saying like it would be like super long paper with like a rolling tape of punch cards, I guess. But like, was that used in the 2000s? I'm sure he was a student in the 2000s. I don't know. Anyway, sequence modeling.
then after that I'm going to talk about kind of 3 basic techniques for sequence modeling, namely recurrent neural networks, convolutional networks, and attention.
Okay.
So when we talk about sequence modeling in NLP, I've kind of
Oh, I was like, are these names of things? But then it's tedious and horrendous. Okay. It looks like names of things. I haven't seen a punch card IRL once. I have. Oh, you have. Like some old spares in a book. Didn't seem likely that was. I know, right? I don't think. Maybe he was, but I know he studied in the UK, so I don't know. He just looked young. He could have been a vampire. That's true. He had just gotten his master's. I don't know. I think we were like his first batch of students, and he was so lively and amazing. So yeah, sometimes when teachers are, just lively and fun, it's fun. By the way, he was teaching English, not computer, even though he was a computer teacher, because he had came back from the UK. His English was really good, and they teaching English. UK no upgrades. Ha 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 ha. That's a fun joke. That's a good joke. Yep. It's all UK's fault. Maybe they want to teach, things from scratch, so they had to create the computer, do punch cards, and then upgrade to digital stuff.
Already made the motivation for doing this, but basically NLP is full of sequential data. And this can be everything from words and sentences, or tokens and sentences, to characters and words, to sentences in a discourse or a paragraph or a document. It can also be multiple documents in time, multiple social media posts, whatever else you want. There's just, sequences all over NLP. And I mentioned this last time also, but there's also long distance dependencies in language. So just to give an example, there's agreement in number, gender, etc. So in order to create a fluent language model, you'll have to handle this agreement. So if you say he does not have very much confidence in, it would have to be himself. But if you say she does not have very much confidence in, it would have to be herself.
And if you're using a language that's not gendered, then you're lucky.
And this gender agreement is not super frequent in English, but it's very frequent in other languages like French or, most languages in the world in some way or another. Then separately from that, you also have things like selectional preferences, like the rain has lasted as long as the life of the queen, and the rain has lasted as long as the life of the clouds.
Wow.
In American English, the only way you could know which word came beforehand if you were doing speech recognition is if you had.
That's really difficult for ASR, isn't it? Like, does it have to update the whole sentence? Because I have been, I do use OneNote. Is that the Microsoft one? And the voice note taking, sometimes I use it, and I see updating like the word before it. But that is like super long. That would be impossible to update.
That kind of semantic idea of that these agree with each other in some way. And there's also factual knowledge. There's all kinds of other things that you need to carry over.
Garden path sentences are the real tricky cases. Oh yeah, time flies like an arrow, which flies like a banana. Yeah, true. I mean, that's for understanding, right? But that's for ASR. Yeah, language is not a joke.
For long contexts. These can be complicated. So this is a nice example. So if we try to figure out what it refers to here, the trophy would not fit in the brown suitcase because it was too big. What is it here?
Trophy.
The trophy, yeah. And then what about the trophy would not fit in the brown suitcase because it was too small? Suitcase, right? Yep. Does anyone know what the name of something like this is?
Nope. I have problem parsing the complex houses, married and single soldiers and their families. Whoa. That's a sentence? Hint and love that. The suitcase one? Yeah, suitcase one. I've heard it before. Let me try to parse this sentence. Complex houses, married and single soldiers and their families. Wait. Oh. Sorry. Yeah, thank you. My brain didn't work. Okay. Complex. Houses. Takes several reads to click. Single soldiers and their families. What's with the and? My problem is with the and between married and single. Oh! The complex houses, married and single soldiers. Wait, no. What's happening? Point of, like these garden path sentences, they illustrate that language understanding is difficult. Absolutely, yeah. Yeah, agreed. Language understanding. NLU, right? Yeah, that's a thing. That's a whole research thing. Let's see if we get any other examples. Married and single soldiers are housed within the complex. Single soldiers. Okay. Okay. That helps. Oh, garden path. Is that?
Has anyone heard of this challenge before? No one? Okay. This is called the Winograd Schema Challenge, or these are called Winograd schemas. And basically, Winograd schemas are...
I didn't know about... Did I know about it? I don't know. Have a memory of a goldfish.
A type of... They're a type of kind of linguistic challenge where you create two paired examples that you vary in very minimal ways, where the answer differs between the two. And so there's lots of other examples about how you can create these things, and they're good for testing whether language models are able to do things, because they're able to kind of control for the fact that, you know, like the answer might be, the answer might be very, like, more frequent or less frequent, and so the language model could just pick that. So another example is we came up with a benchmark of figurative language where we tried to figure out whether language models would be able to interpret figurative language. And I actually have the multilingual version on the suggested projects on the Piazza. Oh yeah, that's one announcement. I posted a big list of suggested projects on Piazza. I think a lot of people saw it. You don't have to follow these, but if you're interested in them, feel free to talk to the contacts and we can give you more information about them. But anyway, so in this data set, what we did is we came up with some figurative language, like this movie had the depth of a wading pool, and this movie had the depth of a diving pool. And so then after that, you would have two choices. This movie was
good or bad?
Was very deep and interesting. This movie was not very deep and interesting. And so you have these like two pairs of questions and answers, and you need to decide between them. And depending on what
has a very drop-off teaching style, as in he just gives the information like that. Feels like the suitcase one implies something like a world model just to answer questions of what it means. Same with the pool thing. Like if you don't know diving pool with the other type of pool that I don't know what it was, but it's shallow, then yeah, without a world model, you are in trouble. I don't know what you mean by a drop-off teaching style. I don't know if it's a good thing or a bad thing. Keeping the audience engaged. He is amazing at that, isn't he?
The input is the output will change, and so that's a good way to control for and test whether language models really understand something. So if you're interested in benchmarking or other things like that, it's a good paradigm to think about. Anyway, that's a little bit of an aside. So now I'd like to go on to types of sequential prediction problems. And Types of prediction problems in general, binary and multi-class we already talked about. That's when we're doing...
By the way, I have the background noise on, and one part is the coffee shop people sound, and when I hear them talking, I think it's the professor, so I'm going to shut that part off. Because I hear people speaking, and I'm like, who's that? So yeah. Yes, maybe the coffee shop one, yeah. I added a bit more rain. Let's lessen the waves. Should we do some more wind? And turn off the fire? It did sound like the class, the people in the class were talking. I was like, that's rude. Okay, now we have wave, wind, run, and rain and thunder. Fire is turned off, and you can definitely tell because the fire is the thing that was crackling. Okay. So this is more calm, isn't it? Oh, no. Okay.
Problems in general, binary and types of prediction problems in general, binary and multi-class we already talked about. That's when we're doing, for example, classification between two classes or classification between multiple classes. But there's also another variety of prediction called structured prediction. And structured prediction is when you have a very large number of labels. It's not, a finite number of labels. And so that would be something like if you take in an input and you want to predict all of the parts of speech of all of the words in the input. And if you had like 50 parts of speech, the number of labels that you would have for each sentence is, any ideas?
Times 3?
50 parts of speech and like, let's say 4 words.
4 times
60?
I don't know.
It's every combination of parts of speech for every.
Paying attention? Should I pay attention? Is this going on the test? But now I'm thinking about the class project. Because I know they have class projects, but the only one I see on the site is assignment 1 and assignment 2. What happened? Yes, I want to go to the site. Assignments. There are 4 assignments. 1, 2, and 3, and 4. See, this is assignment 1. So, maybe... Oh, projects! Did they already do assignment 1? Wait, no. I remember looking at the date and being like, this is January. This was supposed to be in February. I don't think they have already done assignment 1. Hello, hello. So JSS transformers are ahead of this lecture. Yes, you're right. It's the next one. So I'm guessing that's when they do this assignment. And then those leaving pages always break my chain of thought. I know. The irony is that my break sales. Oh, mine has been broken. Hi, Alfin. Hello, Alfin. We are from all over the world. The people that are here. You are getting lost in the schedule. I am, lost in the sauce of the assignments. It's my favorite thing, giving attention to things that don't matter and not the things that matter. So, the part of speech. By the way, Alfin, where am I from? Who? Me? Iraq, however you want to say it. Somewhere in the Middle East. My accent does not give me away. I don't know if that's a good thing or a bad thing. let us know if you are interested in ML stuff. Or if you want to study with us. So, yeah, part of speech for words.
Every word. So
Every combination of part of speech for every word? Isn't that a lot? Because I thought it'd be like each word would get its own 3-letter thing. I don't know.
Close, but maybe the opposite. It's
Less?
50 to the 4, because you have 50 choices here, 50 choices here. So it's a cross product of all of the choices.
That's so much.
And so that becomes very quickly untenable. Let's say you're talking about translation from
I don't know about the MERN stack. What is that? Is that software engineering or is that ML?
English to Japanese. Now you don't really even have a finite number of choices, because the length could be even longer. The length of the output could be even longer than that.
So in general, like 50 parts of party speech, but they follow certain rules that these two not related that together. Like these two have the truth, which makes it like fewer than this is.
Yeah, so really good question. So the question or comment was, if there are certain rules about one thing not ever being able to call the other, you can actually reduce the number. You could do that with a hard constraint.
Adding rules saying that after subject there cannot be another subject, so then it's not 50, it's less.
Kind of in like actually.
Software engineering. Web dev. Yeah. Right now we're learning about natural language processing, which is mostly thank you. Don't remember all the web dev stack code, nor do I. MongoDB, Express, React, and Node.js. Yeah, I will say I'm a bit outdated when it comes to web dev. Yeah, my information is not up to date. I stopped somewhere like in the 2020s. Machine learning, yeah. Basically, we're learning about how stuff like ChatGPT should work, yeah. Especially the next lecture would be basically that. Finally grained the answers as well as the pointing out. Not learning about machines, making machines learn. Haha, both. Oh yeah, machine learning. I had a sticker that says I'm teaching this machine how to think. Or how heavy math is this? Oh, so far, how heavy is the math in this course? Most of the time he's like, here's the math, and then we look at it and he's like, you don't have to memorize it. I'm like, whew. I go by CL. Or Code Life, which is the name of the channel, but CL mostly. So yeah, keen. I don't know if you've had the chance to go and look at the other lectures, but math is mathing. I'm just not learning it. Multi-class and structured according to the slide, etc. Oh yeah. Oh, okay. Oh, okay. You were answering about the got it. Yeah, there are slides that you can look at actually. Do you want to do that? I'm planning to go through it later. Yes, there are more than 20. Okay. Here's let's go to lectures. These are like names, but if you like go to, should you go to language modeling and then look at the slides and just like quickly just go through the lectures, and then you can see some mathing. Where are the maths? See? He does give finally grain answer. Wait, sorry. Yeah. Do you want me to give you the link again? Because I don't mind doing that. Here's the link to the list of videos. So for Alphin, you can do ML with JavaScript, definitely. I'm sure there are courses on that, but I'm currently not taking them, so I am more interested in Python. Yeah. And let me see.
Cut off things that have zero probability, but in reality, what people do is they just trim hypotheses that have low probability, and so that has kind of the same effect. Like you almost never see a determiner after a determiner in English, and so yeah.
I don't know if JSS is referring to the last question he asked about the part of, I think it was part of speech, just the tagging stuff, but. Oh, type of predictions if it's finely grained answer, as in like classification, like that, or if it's something less identified. I don't know.
We're going to talk about algorithms to do this in the generation section, so we can talk more about that then. But anyway, the basic idea behind structured prediction is that you don't, like language modeling, like I said last time, you don't predict all of the whole sequence at once. You usually predict each element at once and then somehow calculate the conditional probability of the next element given the current element or other things like that. So that's how we solve structured prediction problems. Another thing is unconditioned versus conditioned prediction. So unconditioned prediction, we don't do this very often, but basically we predict the probability of a single variable or generate a single variable. And conditioned prediction is predicting the probability of an output variable given an input like this.
Oh, I need to go back. I didn't. Okay, predict single or?
A single variable or generate a single variable. And conditioned prediction is predicting the probability of an output variable.
Ah, okay. Got it. Yeah, if you want to use ML, TensorFlow Lite, machine learning, and run them on GPU using WebGL. But for learning how model works, some Python might be best unless you want to make very small toy NLP models to just understand, or just the ML models to understand concepts. Prediction based, as in drilling deeper into the data. Makes sense? Okay. Is it like a decision tree? Or giving concise answers? Okay. Ah. Interesting.
Input like this. So for unconditioned prediction, the way we can do this is left to right autoregressive models. And these are the ones that I talked about last time when I was talking about how we build language models.
Yes.
And these could be...
Should I remember them?
Specifically, this kind, though, is a kind that doesn't have any context limit. So it's looking all the way back to the beginning of the sequence. And this could be like an infinite length n-gram model, but practically we can't use those because they would have too many parameters. They would be too sparse for us to estimate.
Answer could be yes, or answer could be yes, it was great. Okay, I see.
The parameters. So what we do instead with n-gram models, which I talked about last time, is we limit the context length. So we have something like a trigram model where we don't actually reference all of the previous outputs when we make a prediction. Oh, and sorry, actually, I should explain. How do we read this graph? So this would be, we're predicting number 1 here. We're predicting word number 1, and we're not conditioning on anything after it. We're predicting word number 2. We're conditioning on word number 1. We're predicting word number 3.
I see. So this becomes what comes before it. I thought it would be like, this is 1 given what's behind it. No, that makes more sense. And this here has only 2 things before it. Okay, that makes sense. Yes. Deep, yeah. Deep ML, require a lot of compute. JavaScript is not good. There is ML that can be done in JavaScript, but maybe not with large language models.
We're conditioning on word number 2. So here we would be predicting word number 4, conditioning on words number 3 and 2, but not number 1. So that would be like a trigram model. So the what is this? Is there a robot walking around somewhere? Power drill. Okay. Be a lot more fun if it was
Power
a robot.
drill. Okay.
So the things we're going to talk about today are largely going to be ones that have unlimited length context, and so we'll talk about some examples here. And then there's also independent prediction. So this would be something like a unigram model, where you would just not condition on any previous context.
Okay, to just look at this, we have x I to x, and then x, probably of x given 1 to I minus 1, but here I minus n plus 1. So this is like everything, and this here is like just the window that I give you, and then here is just probability of xi. That's it. My last comment? Oh wait, what happened? Sorry. That's more like sentiment analysis. My last comment and current slides. Oh yeah, the thing, classification. RNN and transformers have unlimited context window? No. Pretty sure in practice there's a limit. Yes. We were learning about the window in HuggingFace, actually. In the, I think it was using or the fine-tuning, probably using. The window is like really big, but it's still a window. RNN has no context window? No way. Have a somewhat limited context window. Open problem to try and extend it. Lots of work in this area, probably. But yeah, like if you want to use models, they have windows, 100%. I think, like, that's what I remember. TensorFlow Lite, good for inference in JS, but not training. So you just use it. Okay. Fun. I was looking at the formula in the slide. Yes. There it is. For this one, it looks like there is no window. Yeah.
There's also bidirectional prediction, where basically when
this is the thing with the encoder decoder, right? With the bidirectional access.
you predict each element, you predict based on all of the other elements, not the element itself. This could be something like a masked language model. But note here that I put a slash through here because this is not a well-formed probability, because as I mentioned last time, in order to have a well-formed probability, you need to predict the elements based on all of the elements that you predicted before, and you can't predict based on future elements. So this is not actually a probabilistic model, but sometimes people use this to kind of learn representations that could be used downstream for some reason.
Is that different from
is this clear?
Bidirectional, the thing with the decoder? Or because I know masked language models also a thing.
Questions, comments? Yeah. So these are all not conditioning on any prior context. So when you predict each word, it's conditioning on context that you previously generated or previously predicted.
I think like positional encoding, embedding, limits, context length, extrapolation.
Yeah. So and if
I'm nodding my head as in yes. Does it look like I'm nodding my head?
I go to the conditioned ones, these are where you have like a source X, where you're given this, and then you want to calculate the conditional probability of something else. So to give some examples of this, this is autoregressive conditioned prediction. And this could be like a standard sequence-to-sequence model, or it could be a language model where you're given a prompt and you want to predict the following output, like we often do with ChatGPT or something like this. And so,
yeah, I guess. Like you can give a transformer model trained with 2048 token context, a bigger context, but it may not work very well. Pre-trained, right?
yeah, I don't think you can. Yeah, I don't know if any way you can do ChatGPT without any conditioning context. But there were people who were sending, I saw this about a week or two ago, there were people who were sending things to the chat, to the GPT 3.5 or GPT-4 API with no input, and it would randomly output random questions or something like that. So that's what happens when you send things to ChatGPT without any prior conditioning context. But normally what you do is you put in, your prompt, and then it follows up with your prompt, and that would be in this paradigm. There's also something called non-autoregressive condition prediction. And this can be used for something like sequence labeling or non-autoregressive machine translation. I'll talk about the first one in this class.
I just remember reading autoregressive somewhere in the transformer model and being like, what is that? And then now we understand, I guess. Was it here? Auto. Yeah, there it is. Yeah, see, it's talking about how this works. Send it to space, yeah, and then it's like it predicts as if it's answering you.
I'll talk about the second one maybe later. It's kind of a minor topic now. It used to be popular a few years ago, so I'm not sure whether I'll cover it, but yeah.
That's it?
Cool.
We're done for today. I'm done. I mean, you guys can continue learning for if you like. But yeah, I would call today a success. Where were we? Let's do a recap. We just double checking. Yep. Okay. We did introductions to the datasets library, and then what if my dataset isn't on the hub? So loading datasets that are either local or remote. That's the first part. I mean, that was like an hour and 20 minutes, so I wouldn't call that. So next thing would be slicing and dicing our data, pre-processing, I'm guessing. And then we looked at sequence modeling and the different types of predictions. Oh yeah, the thing with the I forgot the name. Hold up. Winegard schema challenge. And then types of predictions, binary, multiclass, and structured. And then conditional, unconditional, I think. And then we looked at unconditional prediction. And then also conditional prediction. And the difference was that target versus with a window or without a window. Single variable or based on something, as if it's answering. Okay, now I feel like I understand it. Because this is sequence model, and this is machine
Used to be
translation?
popular a few years ago, so I'm not sure.
Hold up. Sequence labeling and autoaggressive machine translation. There we go. What lectures do you think we should get to before we attempt assignment one ourselves potentially? My brain is telling me transformers has to be explained before we try and make a transformers. Does that make sense? Let's see when that was. Let's get lost in the February 7th. That makes sense to me. See? Llama architecture. Right? What do you think? Checkpoint, restart, training. Yeah. Looks like they're talking about llama, so I'm guessing that's when you should give the assignment for llama. Because that's what the assignment is. Okay. 성공, which means success. Yep. I think the headphone is a beaver. I think. Okay. I missed at least 11 or 12 of your videos, so I should catch up. You don't have to, you can just catch up with the professor, right? Or HuggingFace yourself, whichever you're more comfortable with. If the videos help, then do that. If not, you don't have to. It can be like background noise. Yeah. Really, thank you for joining me with the learning. It does really make it more fun when we are learning together. And I hope that we can be like a study group. By the way, I actually don't mind. Is your old costume like Castrel from Supernatural? Oh, the one with the black one? Which one? Because I don't mind. Also, I haven't seen Supernatural. Do forgive me for that. Thank you, Keen. You're being so nice. I was about to say thank you. You guys are kind. We can do some sort of study group style channel on Discord, just to help each other if there are questions or whatever. Because that's my main reason of, learning online, to help each other. So I think I should do that. I'm gonna check how Castrel looks from Supernatural, because I don't mind playing dress up. Oh, the coat? The coat? I'm gonna try that. We have Discord in the doobly-doo, yes. Oh yeah, sure, happily. Next time. Yeah, the loose necktie was the blue jacket, I think. And yesterday I learned the word for necktie in Korean, which was necktie. That was really funny. Okay. So, thanks for, today's Wednesday, right? Yeah, surprising. The week has gone by. Thank you for being here and learning with me. I really do hope that we can learn together better instead of individually. I was like, how do I know what necktie is supposed to mean? And then yesterday I beat the Korean test on Duolingo. Like I got it 100%. I was like, I was so proud of myself. I'm gonna probably make that into a video because I like watching people do the Duolingo tests. Not related, but fun. Yeah. Yep. A lot of English words in a lot of languages, or just like how a lot of Arabic words are in English. Yes, good game. Okay, if all goes well, I'll see you tomorrow. If not, have a lovely rest of the day, and catch me next time whenever is possible for you. Thank you, SK Ferdin. I don't think you've been. I've seen you chat before, but thank you for telling me that I'm being consistent, and I appreciate that. Yeah, see you tomorrow, inshallah. Do let me know if you need anything. I will most likely answer things on Discord. If you'd like to say hi, do that. See ya. Ending the stream in 5, 4, 3, 2. Thank you. Okay, thanks for catching. If you'd like to say hi on Discord, do that. Otherwise, catch you tomorrow, inshallah. 2 and then 1, I think. Bye.